Whenever we start working on a new dataset, it is important to get an idea of the dataset quality. Therefore, understanding data properties in 3D is the first step that we will cover in this tutorial. The Gliamorph tool analyzes data in 3D. Therefore, users need to be aware and equally assess for all the X, Y, and Z dimensions of an image. A voxel is a graphic unit representing a point in 3 dimensions. It is basically a pixel, but in 3D. Therefore, throughout our Gliamorph tool analysis, we will be referring to voxels. Another important point that we need to check for is z-axis decay. In confocal images, the penetration decreases over the z-axis, so over the depth of the 3D image. This leads to uneven data quality in the 3rd dimension. Therefore, the stacks on the top have better signal quality, however, the stacks in deeper layers of the image do not. We will now go through the steps to examine these voxel properties. We start by dragging and dropping the image onto the Fiji tab, and when it loads, you will see something like this. There's 2 sliders at the bottom. C refers to the color channel. In this case, we have red and green stains, and Z refers to the depth or the 3rd dimension. And we scroll up and down throughout the stacks to visualize the signal and whether there has been any decay along the depth. To examine the dimensions of our voxels, we will go to Fiji image and click on properties. This will open a tab showing information on channels, slices, frames, and voxel XYZ dimensions. Channels, as we mentioned, are 2, consisting of red and green. Slices are, in this case, 64, and this refers to the slices, to the 64 slices that have been stacked together to form the 3D image. The frame refers to the point in time where the image was taken, and this was a single frame image, so taken at one moment rather than throughout time. And the dimensions of the voxel that we can see here are width, height, and voxel depth. Due to resolution limits, voxels are typically longer than they are tall or wide. Therefore, they have a rectangular shape. In this case, it is important to check that these rectangular dimensions are maintained and they do not have a falsely cuboid appearance where height, width, and depth would be the same. Another error that can commonly occur at this step is an interchange between slices and frames. Therefore, we would see frames as 64 and slices as 1. Knowing what each of them refers helps us check against this error. To now visualize our image in 3D, we need to use our Fiji 3D viewer. So keep the image open and we click on Plugins 3D Viewer. A tab will appear, to which I simply click OK, and we await for a 3D image to appear. In this case, I will demonstrate a typical error where an image does not show and instead you get a blank tab. This means that sometimes the image can be quite large for Fiji to process. What we can do instead is use a smaller cropped image that has been produced using the subregion macro. This macro will be explained to you over the next few videos, but for now let's go back to the 3D viewer. We should select 2 for the resampling factor in order to make it easier for our computer to process the image. You can then use your mouse to rotate the 3D image in different angles where you can fully visualize it, and if you wish you can double click on the mouse to see a red box outlining the edges of your image. Thank you for watching. Please continue to the next video where we will start going through the macros.